Hello there, welcome to Patex Academy. This is question number 2 that talks about differentiation of functions that will require both product rule and chain rule. In our previous lesson, we look at only chain rule being involved. So please, if you want to watch, I have just given some link in this part here, and you can take that and watch before you continue the video. Now, without wasting time, let's have a look at part A of this question, which says x square y plus x y square is equals to 3x. So we can start by writing ddx of the left hand side, and that is x square y plus x y square. Then we also do the same to the right hand side, ddx of, here we have one term and that is 3x. Now we can distribute this ddx to this term and the second term here. So we have dx of the first term x square y, and then plus dx of the second term, and that is xy square equals to, now this time we can differentiate this directly because this one is just an easy part here, and that differentiate to 3. Now when you look at the left hand side, we realize that we have x and y in the two terms, so this is where product rule come in. So with product rule, we start with u, the u value here is x square, so let's have x square times dx of v, and that is y. Then we add it to v, and now v here is y, then dx of u, and now v here is x square. So this is the first term, and the second term here we also do the same. So we start with the x, dx of y square, then plus y square as v, then dx of x, so equals to 3. Now we can go ahead and differentiate each one of these terms one by one. And since this one here is y and we are differentiating with respect to x, then we use chain rule here. So the first term differentiate to x square, also dy by dx. Taking note that here we can split this as dx of, so dy of y, and then multiply it by dy by dx, such that these two terms correspond, and if you cancel it will take you back to dx, which has just been here, and multiply with our y. So with that, with our x, sorry. So here, this differentiate to the term here. Now, since this one is with respect to x, we just direct the derivative of x square is 2x times y is 2x y. And then we move on to the next term, and this term is also the same way. We differentiate it listly, so we have 2y times x, and that is plus 2xy, but this time with dy by dx attached, since we are differentiating with respect to x and the quantity is y. So we move to the last one, the derivative of x goes to 1 times y square, we have plus y square, and this is equals to 3. Now we can connect these terms with dy dx together, then we have here x square, so the next coefficient here is 2xy, so we factor out dy by dx, and then we write the remaining terms to the second side here. So let's subtract this away. We have 2x, y, and also subtract y away because we are just transferring from the left hand side to the right side. And then to isolate dy dx, we just divide both sides by the coefficient x squared plus 2xy. Therefore, our dy by dx equals 3 minus 2xy minus y squared all over x squared plus 2xy, and that is the derivative of the first part. So please watch up to the end of this video because I'm going to give you some checking points to see that you have understood. And in case you're not understood, rewatch the video, pause, make notes, and then you'll be able to answer that part. But the good news is I will give you the answer as well, and then you'll be good to go. So let's move on to part number 2 in our next board. Now part B of the question is saying x squared plus xy plus y squared equals 4. So here we do the same as before, ddx of the left hand side, x squared plus xy plus y square, and then the right hand side dx of our constant 4. Now we can distribute again. We have dx of the first term, and then this x squared, plus dx of the second term, and that is xy, plus dx of the third term, and that is y squared, equals to the derivative of the constant is 0. So let's differentiate the first term, and that is 2x. Then the second term we differentiate implicitly. So we have here, applying product rule, we have x starting, then the y by the x follows, plus this time y follows, then the dx of the second value here, that is x. So plus, now here we can differentiate directly. Here we have 2y, then dy by dx equals to 0. Now we can differentiate the remaining term, looks like this one here. So we have 2x plus this one remains x dy by dx. Then the other one goes to 1 times y is y. So plus this one has been differentiated already. So we have 2y dy by dx. Grouping terms with y, correctly the coefficient, we have x plus 2y, then multiplying by the derivative function dy dx equals to, now we transfer the remaining terms to the other side. So we have here negative 2x minus 1, and then divide both sides by the coefficient of dy by dx. This one yields negative 2x minus 1 over x plus 2y. That is the solution for this question here. I hope we are all getting together well, and let's look at the last number that we have a look at the checkpoint. Now the last number C is saying sine of x y must be equals to a half. So let's do the same. Dx of our sine into xy, and then dx of a half. Now the right hand side will go to 0. The derivative of sine, we just consider xy to be 1 over, like say theta is cos theta. So in that case we have cos, and where our product rule comes in. So let's maintain our cos xy here, then we differentiate this one here also in implicit manner, where we start with the x, then dy by dx plus y dx of x, and then equals to 0. So let's go ahead and differentiate it and have our cos xy going to multiply x dy by dx, then plus this one goes to pi. We have here y is less than plus 1 is to 1 equals to 0. Then you can open up this bracket by multiplying through. So here we have x times cos xy, then dy by dx plus cos xy times y equals to 0. Then we are more interested in our dy dx alone, so we can isolate this by first of all taking it to the other side and maybe taking it up here. We have x cosine of xy should be dy by dx should be equals to negative y cosine of x y. Now dividing both sides by this, the left hand side will be remaining with dy by dx equals to negative y cos x y, then over x cos x y. So we can narrow down by counting this, narrow down here from the numerator and denominator, and we will get the remaining terms as our answer. Therefore, dy by dx is simply negative y over x, and that is the answer for the aspect of this. Let's move on to the checkout point. Now here's the checkpoint, and we have the question here, and the solution is somewhere here. So go ahead and try this number out to check that your answers will be exactly like here. Thank you for watching, and see you in the next one. Goodbye.